What's up, math scholars and math haters? This is Mr. W. We're going to tackle question 11 in the 4th grade math questions that North Carolina released this past school year. We see that Pablo was getting ready for a bike race. He rode his bike each day for 32 days, and he rode his bike for 45 minutes each day. How many minutes did Pablo spend riding his bike to get ready for the race? To do really well in a question like this, you're going to need to know how to translate a problem like this, as well as how to multiply bigger numbers. Like, you'll need to use more than just your times tables to figure these out, even though every big multiplication problem does break down to the little multiplication problems that we do with our times tables. So we have Pablo getting ready for a bike race, and I see the word each here not just once, but twice. And if y'all have watched any of my other videos where I translate a problem like this, you know that the three big words that tell me I'm going to multiply are each, every, and per. If I see any of those, I know that I'm going to have to multiply something. Specifically, I'm going to have to multiply the number of days that Pablo's training by the number of minutes that he trains for every day. And in this case, I can go ahead and fill in some of that information. That's 32 days times 45, and I know that's going to equal my total. In most other problems, this unknown number would be somewhere on the left side, and we'd have to do some fact family workarounds to get it by itself so we could have just one math thing to do. But now, we just have to multiply 32 and 45, and this is where that idea of multiplying bigger numbers comes in. Now, I'm going to do this two ways. I'm going to do this the way that I remember being taught, and then I'm going to do it in a way that I was trained to teach with, that I think is really in line with what Common Core does. So I'm going to do it both ways. We'll get the same answer, and for you parents who are thinking, Common Core, oh no, I'm freaking out right now, we'll be fine. We will be completely fine. So to start with, I'll do it the way that I was taught. If I see, I'll use a red marker for this, 32 times 45, I'm going to start with my ones digit in my bottom factor. I'm going to multiply it up. 5 times 2 is 10. So I'm going to put my ones digit of 10 there, and my tens digit of 10 up there. And now I'm going to multiply 5 times 3, which is 15. 15 plus 1 is 16. So that's 160 for my top row, and we can kind of see that we just multiplied 32 times 5 to get this 160, so that checks out. And now I have to cross this out, and because now it's like we're multiplying by 40, I'm going to start by putting another 0 down here as I go through and multiply the rest of this. So 4 times 2 gives me 8, 4 times 3 gives me 12. I don't need to carry any numbers this time because I'm at the far left end of the problem. And so now I just need to add all this together. 0 ones plus 0 ones still gives me 0 ones. 6 tens plus 8 tens gives me 14 tens, also known as 1 100 and 4 tens. So 1 100 plus 1 100 plus 2 100s gives me 4 100s. And now I don't have to do anything with the thousands, I just have the 1, so that's 1,440 minutes, which does match my answer choice of D. So I'm going to go ahead and circle that. For those of you who want to see the other method that I know some people like to use, I learned this in training, but I actually got it first from one of my students. The idea is that you split each number up into 30 plus 2, and then 40 plus 5, and you draw a box. You figure out each individual multiplication problem, and then you add all of those together. So to start with, and I'm actually going to do these in the same order that I did them in the what's called the standard algorithm as I learned it. 5 times 2 is going to just give me 10. 5 times 30 is going to give me 150. Now, 5 times 2 gave us 10 over here, and 5 times 3 gave us 15 here, so we can still see where we have some of the same numbers. But now I'm going to go ahead and tackle 40 times 2, which is 80, and now 30 times 40, I have 2 zeros, so I'm going to do 3 times 4 is 12, write out my 2 zeros, and that's 1,200, And now we just have to add all these together. 1200, 150, 80, and 10. All my zeros add to 0. 5 plus 8 plus 1 gives me 14 tens. 1 100 plus 2 100s plus 1 100 gives me 4 100s, and then 1,000 just stays like that. So either method gave us the same answer, which was 1,440, and I just wanted to demonstrate how both of these methods have a lot of validity in terms of how we use math to work out the multiplication, and they both give us the same answer. So have both in your back pocket when you do a problem like this.